There are three main hypotheses concerning the evolution of lactose tolerance. The first two hypotheses are the most scientifically accredited. The first claims that lactose tolerance arose due to the change in diet that resulted from farming, and the second hypothesis claims that lactose tolerance is a result of genetics. When farming was introduced in northern Europe and northern Africa between 7,000 and 9,500 years ago, the human diet began to include dairy. The evolution of lactase persistence in humans closely followed this dietary change. Cattle farmers and their descendants displayed persistence of lactase activity throughout adulthood in order to obtain nutrients from consumed dairy products. Ultimately, those with lactose-tolerant genotypes likely left more offspring as a result of better health and fitness from additional nutrients they received from dairy products. Due to the dominant inheritance of the lactose-tolerant genotype, offspring with at least one lactose-tolerant parent have a 50%, 75%, or 100% chance of also being lactose-tolerant. If one parent is lactose intolerant and the other is heterozygous lactose tolerant, the offspring have a 50% chance of being lactose tolerant. If both parents are heterozygous lactose tolerant, the offspring have a 75% chance of being lactose tolerant. If at least one parent is homozygous lactose tolerant, the offspring have a 100% chance of also being lactose tolerant. As a result of an environmental and dietary change, lactose tolerance genotype became more abundant among the population. The third hypothesis, by scientists Flatts and Rotow, claimed that the evolution of lactose tolerance arose because calcium absorption is improved with vitamin D and lactose hydrolysis. At the time, many northern Europeans suffered from insufficient calcium absorption, which resulted in pelvic deformations in many women, causing them to leave fewer offspring. In terms of natural selection, this hypothesis claims that lactose-tolerant women were able to avoid these bone deformations and leave more offspring, thus increasing the prevalence of the lactose-tolerant genotype within the population. While this hypothesis may be accurate for northern Europeans, it does not explain the need for the evolution of lactose tolerance in areas like northern Africa, where calcium malabsorption is not very common due to the abundance of sunlight and vitamin D.